The Virginia class, also known as the SSN 774 class, is a class of nuclear-powered fast attack submarines in service with the United States Navy. The submarines are designed for a broad spectrum of open ocean and littoral missions. They were conceived as a less expensive alternative to the Seawolf-class attack submarines, designed during the Cold War era. They are replacing older Los Angeles-class submarines, many of which have already been decommissioned. Virginia-class submarines will be acquired through 2043, and are expected to remain in service past 2060. Based on recent updates to the designs, some of the Virginia-class submarines are expected to still be in service in 2070. History. The class was developed under the codename Centurion, renamed to an SSN later on. The Centurion study was initiated in February 1991. Virginia-class submarines were the first U.S. Navy warships designed with the help of computer-aided design and visualization technology. By 2007, approximately 35 million labor hours were spent on designing the Virginia class. Around 9 million labor hours are required for the construction and completion of a single Virginia-class submarine. Over 4,000 suppliers are involved in the construction of the Virginia class. Each submarine is projected to make 14-15 deployments during its 33-year service life. The Virginia class was intended in part as a less expensive alternative to the Seawolf-class submarines, whose production run was stopped after just 3 boats had been completed. To reduce costs, the Virginia-class submarines use many commercial off-the-shelf components, especially in the computers and data networks. In practice, they actually cost less than $1.8 billion each, due to improvements in shipbuilding technology. In hearings before both House of Representatives and Senate committees, the Congressional Research Service and expert witnesses testified that the procurement plans of the Virginia class, 1 per year, accelerating to 2 per year beginning in 2012, would result in high unit costs and an insufficient number of attack submarines, according to some of the witnesses and the committee chairman. In a 10 March 2005 statement to the House Armed Services Committee, Ronald O'Rourke of the CRS testified that, assuming that the production rate remains as planned, production economies of scale for submarines would continue to remain limited or poor. In 2001, Newport News Shipbuilding and General Dynamics Electric Boat Company built a quad-scale version of a Virginia-class submarine dubbed Large Scale Vehicle 2 Cutthroat. The vehicle was designed as an affordable test platform for new technologies. The Virginia class is built through an industrial arrangement designed to keep both GD Electric Boat and Newport News Shipbuilding in the submarine building business. Under the present arrangement, the Newport News facility builds the stern, habitability, and machinery spaces, torpedo room, sail and bow, while Electric Boat builds the engine room and control room. The facilities alternate work on the reactor plant as well as the final assembly, test, outfit and delivery. O'Rourke wrote in 2004 that, compared to a one-yard strategy, approaches involving 2 yards may be more expensive but offer potential offsetting benefits. Quote, among the claims of offsetting benefits that O'Rourke attributes to supporters of a 2-facility construction arrangement is that it would permit the United States to continue building submarines at 1 yard even if the other yard is rendered incapable of building submarines permanently, or for a sustained period of time by a catastrophic event of some kind, including an enemy attack. In order to get the submarine's price down to $2 billion per submarine in FY05, the Navy instituted a cost reduction program to shave off approximately $400 million of each submarine's price tag. The project was dubbed 2 for 4 in 12, referring to the Navy's desire to buy 2 boats for $4 billion in FY12. Under pressure from Congress, the Navy opted to start buying 2 boats per year in FY11, meaning that officials would not be able to get the $2 billion price tag before the service started buying 2 submarines per year. However, Program Manager Dave Johnson said at a conference on the 19th of March 2008 that the program was only $30 million away from achieving the $2 billion price goal, and would reach the target on schedule. The Virginia-class Program Office received the David Packard Excellence in Acquisition Award in 1996, 1998, 2008, for excelling in 4 specific award criteria: reducing life cycle costs, making the acquisition system more efficient, responsive, and timely, integrating defense with the commercial base and practices, and promoting continuous improvement of the acquisition process. In December 2008, the Navy signed a $14 billion contract with General Dynamics and Northrop Grumman to supply 8 submarines. The contractors will deliver 1 submarine in each of fiscal 2009 and 2010, and 2 submarines on each of fiscal 2011, 2012, and 2013. This contract will bring the Navy's Virginia-class fleet to 18 submarines, and in December 2010, the United States Congress passed a defense authorization bill that expanded production to 2 subs per year. 2 submarine per year production resumed on the 2nd of September 2011 with commencement of Washington construction. On the 21st of June 2008, the Navy christened New Hampshire the first Block II submarine. This boat was delivered 8 months ahead of schedule and $54 million under budget. Block II boats are built in 4 sections, compared to the 10 sections of the Block I boats. This enables a cost saving of about $300 million per boat, reducing the overall cost to $2 billion per boat and the construction of 2 new boats per year. Beginning in 2010, new submarines of this class will include a software system that can monitor and reduce their electromagnetic signatures when needed. The first full-duration 6-month deployment was successfully carried out from the 15th of October 2009 to the 13th of April 2010. Authorization of full rate production and the declaration of full operational capability was achieved 5 months later. In September 2010, it was found that urethane tiles, applied to the hull to damp internal sound and absorb rather than reflect sonar pulses, were falling off while the subs were at sea. Admiral Kevin McCoy announced that the problems with the mold-in-place special hull treatment for the early subs had been fixed in 2011. Then Minnesota was built and found to have the same problem. Professor Ross Babbage of the Australian National University has called on Australia to buy at least a dozen Virginia-class submarines from the United States, rather than locally build 12 replacements for its Collins-class submarines. In 2013, just as 2 per year sub construction was supposed to commence, Congress failed to resolve the United States fiscal cliff, forcing the Navy to attempt to obligate construction funds. Innovations. The Virginia-class incorporates several innovations not found in previous U.S. submarine classes. Technology barriers. Because of the low rate of Virginia production, the Navy entered into a program with DARPA to overcome technology barriers to lower the cost of attack submarines so that more could be built to maintain the size of the fleet. These include propulsion concepts not constrained by a centerline shaft, externally stowed and launched weapons, conformal alternatives to the existing spherical sonar array, technologies that eliminate or substantially simplify existing submarine hull, mechanical and electrical systems, automation to reduce crew workload for standard tasks. Unified modular masts. For the first time in history, the design of the 8 masts in Virginia-class has been unified in a universal modular mast program led by L3KO. Shared components have been maximized and some design choices are also shared between different masts. The first arm was first installed on Memphis, a Los Angeles-class submarine. The arm is an integrated system for housing, erecting, and supporting submarine mast-mounted antennas and sensors. The UMMs are snorkel mast, 2 photonic masts, 2 communication masts, 1 or 2 high data rate satellite communication masts built by Raytheon, enabling communication at super high frequency and extremely high frequency range. Radar mast, an electronic warfare mast used to detect, analyze, and identify both radar and communication signals from ships, aircraft, submarines, and land-based transmitters. Photonics masts. The Virginia-class is the first to utilize photonic sensors instead of a traditional periscope. The class is equipped with high-resolution cameras, along with light intensification and infrared sensors, an infrared laser rangefinder, and an integrated electronic support measures array. 2 redundant sets of these sensors are mounted on 2 and BVS-1 photonics masts located outside the pressure hull. Signals from the mast sensors are transmitted through optical fiber data lines through signal processors to the control center. Visual feeds from the masts are displayed on liquid crystal display interfaces in the command center. The design of earlier optical periscopes required them to penetrate the pressure hull, reducing the structural integrity of the pressure hull as well as increasing the risk of flooding, and also required the submarine's control room to be located directly below the sail fin. Implementation of photonics masts enabled the submarine control room to be relocated to a position inside the pressure hull which is not necessarily directly below the sail. The current photonics masts have a visual appearance so different from the ordinary periscopes that when the submarine is detected, it can be distinctly identified as a Virginia-class vessel. As a result, current photonic masts will be replaced with low-profile photonics masts which resemble traditional submarine periscopes more closely. In the future, a non-rotational affordable modular panoramic photonics mast may be fitted, enabling the submarine to obtain a simultaneous 360 degrees view of the sea surface. Propulsor. In contrast to a traditional bladed propeller, the Virginia-class uses pump-jet propulsors. Originally developed for the Royal Navy's Swift Shore-class submarines, the propulsor significantly reduces the risks of cavitation and allows quieter operation. Improved sonar systems. Sonar arrays aboard Virginia-class submarines have an open system architecture which enables rapid insertion of new hardware and software as they become available. Hardware upgrades are usually carried out every 4 years, while software updates are carried out every 2 years. Virginia-class submarines feature several types of sonar arrays. BQQ-10 bow-mounted spherical active passive sonar array from SSN 784 onwards. A wide-aperture lightweight fiber optic sonar array, consisting of 3 flat panel panels mounted low along either side of the hull. 2 high-frequency active sonars mounted in the sail and bow. The chin-mounted and sail-mounted high-frequency sonars supplement the main sonar array, enabling safer operations in coastal waters, enhancing under-ice navigation, and improving anti-submarine warfare performance. Low-cost conformal array high-frequency sonar, mounted on both sides of the submarine's sail, provides coverage above and behind the submarine. Virginia-class submarines are also equipped with a low-frequency towed sonar array and a high-frequency towed sonar array. TB-16 a TB-34 Fatline tactical towed sonar array. TB-29 or TB-33 thin-line long-range search towed sonar array. Rescue equipment SEIEMK-11 suit, enable ascent from a sunken submarine. Lithium hydroxide canisters that remove carbon dioxide from the submarine's atmosphere. Submarine emergency position indicating radio beacon. Virginia payload module. The Block 3 submarines have 2 multi-purpose Virginia payload tubes replacing the dozen single-purpose cruise missile launch tubes. The Block V submarines built from 2019 onward will have an additional Virginia payload module mid-body section, increasing their overall length. The VPM will add 4 more VPTs of the same diameter and greater height, located on the centerline, carrying up to 7 Tomahawk missiles apiece, that would replace some of the capabilities lost when the SSGN conversion Ohio-class submarines are retired from the fleet. Initially 8 payload tubes silos were planned, but this was later rejected in favor of 4 tubes installed in a 70-foot-long module between the operations compartment and the propulsion spaces. The VPM could potentially carry medium-range ballistic missiles. Adding the VPM would increase the cost of each submarine by $500 million. This additional cost would be offset by reducing the total submarine force by 4 ships. More recent reports state that as a cost reduction measure, the VPM would carry only Tomahawk SLCM and possibly unmanned undersea vehicles, with the new price tag now estimated at $360 minus $380 million per boat. The VPM launch tubes silos will reportedly be similar in design to the ones planned for the Ohio-class replacement. As of September 2013, the Chief of Naval Operations was still hoping to field the VPM from 2027, but deployment now seems unlikely since the Joint Requirements Oversight Council moved the program in February 2013 from the Prompt Strike budget to the main Navy shipbuilding account, which is already under financial pressure. Other improved equipment: optical fiber fly-by-wire ship control system replaces electro-hydraulic systems for control surface actuation. Command and control system module built by Lockheed Martin. Modernized version of the UNTBSY-1 integrated combat system designated UNTBYG-1 and built by General Dynamics AIS. UNTBYG-1 integrates the submarine tactical control system and weapon control system. California was the first Virginia-class submarine with the advanced electromagnetic signature reduction system built into it, but this system is being retrofitted into the other submarines of the class. Integral 9-man lockout chamber. Specifications: builders, GD Electric Boat and HII Newport News Shipbuilding. Length 377 feet, beam 34 feet, displacement 7,800 long tons, payload 40 weapons, Special Operations Forces, unmanned undersea vehicles, advanced SEAL delivery system, propulsion, the S-9G nuclear reactor, 29.8 megawatts delivering 40,000 shaft horsepower. Nuclear core life estimated at 33 years. Maximum diving depth, greater than 800 feet, allegedly around 1,600 feet. Speed, greater than 25 knots, allegedly up to 34 knots. Planned cost, about $1.65 billion each. Actual cost, $1.5 billion, $2.6 billion. Annual operating cost, $50 million per unit. Crew, 120 enlisted and 14 officers. Armament, 12 VLS NAMP, 4 torpedo tubes, capable of launching Mark Chapter 48 torpedoes, usually M109 tactical Tomahawks, Harpoon-S and the new advanced mobile mine when it becomes available. Decoys, acoustic device countermeasure MK 3/4. Boats. Block I modular construction techniques were incorporated during construction. Earlier submarines were built by assembling the pressure hull and then installing the equipment via cavities in the pressure hull. This required extensive construction activities within the narrow confines of the pressure hull, which was time-consuming and dangerous. Modular construction was implemented in an effort to overcome these problems and make the construction process more efficient. Modular construction techniques incorporated during construction include constructing large segments of equipment outside the hull. These segments are then inserted into a hull section. The integrated raft and hull section form a module which, when joined with other modules, forms a Virginia-class submarine. Block I boats were built in 10 modules, with each submarine requiring roughly 7 years to build. Block II boats were built in 4 sections rather than 10 sections, saving about $300 million per boat. Block II boats were also built under a multi-year procurement agreement as opposed to a block-buy contract in Block I, enabling savings in the range of $400 million. As a result of improvements in the construction process, New Hampshire was $500 million United States dollars cheaper, required 3.7 million fewer labor hours to build, thus shortening the construction period by 15 months compared to Virginia. Block III SSN 784 through approximately SSN 791 are planned to make up the third block or flight and began construction in 2009. Block III subs feature a revised bow with a large aperture bow sonar array, as well as technology from Ohio-class SSGNs. The horseshoe-shaped lab sonar array replaces the spherical main sonar array which has been used on all U.S. Navy SSNs since 1960. The lab sonar array is water-backed, as opposed to earlier sonar arrays which were air-backed, and consists of a passive array and a medium-frequency active array. Compared to earlier Virginia-class submarines, about 40% of the bow has been redesigned. Block IV. In 2013, execution of a 10-submarine contract was put in doubt by budget sequestration in 2013. The most costly shipbuilding contract in history was awarded on the 28th of April 2014 as prime contractor General Dynamics Electric Boat took on a $17.6 billion contract for 10 Block IV Virginia-class attack submarines. The main improvement over the Block III is the reduction of major maintenance periods from 4 to 3, increasing each ship's total lifetime deployments by 1. The long lead time materials contract for SSN 792 was awarded on the 17th of April 2012, with SSN 793 and SSN 794 following on the 28th of December 2012. The U.S. Navy has awarded General Dynamics Electric Boat a $208.6 million contract modification for the second fiscal year 14 Virginia-class submarine, SSN 793, and two FY-15 submarines, SSN 794 and SSN 795. With this modification, the overall contract is worth $595 million. Block IV will consist of 9 to 10 submarines. Based on the planned split between Block IV and Block V boats, the Block IV procurement should comprise the following hull numbers. Block V. Block V subs may incorporate the Virginia Payload module, which would give guided missile capability when the SSGNs are retired from service. The Block V subs are expected to triple the capacity of shore targets for each boat. SSN 802, SSN 803, SSN 804, SSN 805, SSN 806, SSN 807, SSN 808, SSN 809, SSN 810, SSN 811. Future acquisitions. The Navy plans to acquire at least 30 Virginia-class submarines. However, more recent data provided by the Naval Submarine League and the Congressional Budget Office seems to imply that more than the 30th of may eventually be built. The Naval Submarine League believes that up to 10 Block V boats will be built. The same source also states that 10 additional submarines could be built after Block V submarines, with 5 in the so-called Block V and 5 in Block 7, largely due to the delays experienced with the improved Virginia. These 20 submarines would carry VPM, bringing the total number of Virginia-class submarines to 48. The CBO in its 2012 report states that 33 Virginia-class submarines will be procured in the 2013 to 2032 time frame, resulting in 49 submarines in total, since 16 were already procured by the end of 2012. Such a long production run seems unlikely, but it should be noted that another naval program, the Arleigh-Burke-class destroyer, is still ongoing even though the first vessel was procured in 1985. However, other sources believe that production will end with Block V. In addition, data provided in CBO reports tends to vary considerably compared to earlier editions. SSN Improved Virginia, initially dubbed Future Attack Submarine, and Improved Virginia-class in Congressional Budget Office reports. The SSN or Improved Virginia-class submarines will be an evolved version of the Virginia-class. In late 2014, the Navy began early preparation work on the SSN. It was planned that the first submarine would be procured in 2025. However, their introduction has been pushed back to 2033-2034. The long-range shipbuilding plan is for the new SSN to be authorized in 2034, and become operational by 2044 after the last Block 7 Virginia is built. Roughly a decade will be spent identifying, designing, and demonstrating new technologies before an analysis of alternatives is issued in 2024. An initial small team has been formed to consult with industry and identify the threat environment and technologies the submarine will need to operate against in the 2050-plus time frame. One area already identified is the need to integrate with off-board systems so future Virginia boats and the SSN can employ networked, extremely long-ranged weapons. A torpedo propulsion system concept from the Pennsylvania Pennsylvania State University could allow a torpedo to hit a target 200 nm away and be guided by another asset during the terminal phase. Targeting information might also come from another platform like a patrol aircraft or an unmanned aerial vehicle launched from the submarine. Researchers have identified a quieter, advanced propulsion system and the ability to control multiple unmanned underwater vehicles at once as key SSN components. The future submarines will operate through the end of the 21st century, and potentially into the 22nd century. New propulsion could come from a biomimetic propulsion system that eliminates noise-generating moving parts like the drive shaft and the spinning blades of the propulsor, moving beyond a rotating mechanical device to push the ship through the water.